Thanks, Moritz. It's always great to see how the ecosystem around the Charmed Operator framework continues to grow. And here, with another example, is Clastix and its integration with Charmed Kubernetes to enable multi-tenancy on the Canonical distribution. Alessio Greggi, please take it away.
Hi, so thank you, David. Welcome, everyone. Welcome to my talk. Today, we are going to talk about the easy integration of Capsule in the Charm ecosystem. But first of all, I would introduce myself. My name is Alessio Greggi. I work as DevOps engineer at Clastix. I'm trying to be an open source contributor day by day. And you can find me on GitHub and Twitter with this unique account, which is Allegray91. So let's start the talk. I would introduce what is Capsule at first. Then I would like to speak about what is a charm. And in the end, as the third point say, I would analyze the anatomy of a charm based on our experience developing it. So the first thing, what is Capsule? Capsule is an open source project developed by Clastix. It is a Kubernetes native operator, and it is used to manage the multi-tenancy in a cluster environment. So you can create different tenants that essentially separate logically the cluster. You can also assign some policies to these tenants in order to apply some limits or to deny some particular behavior by the tenant. So we can define Capsule as a multi-tenancy and policy-based framework. It is really useful to avoid the phenomenon of the cluster sprawl. So what is the cluster sprawl? It is, let's do an example. The cluster sprawl is when a cluster administrator create multiple Kubernetes cluster for each the department or for each application or for each user that needs to use them. But what this action bring is a great amount of management in terms also of costs. So managing a lot of clusters is really difficult to do. So with Capsule, you can avoid this problem using just one cluster instead of having multiple clusters. And doing this, you can have a better management of the single cluster that you have. So you can avoid different upgrades for the different clusters, doing it just one time. So that said, we can see that Capsule is also useful for the governance, and it is also GitOps ready. So let's see in this example how we can create a tenant using Capsule. So after installing the Capsule operator, we can essentially create a tenant filling the manifest, specifying the kind, and this kind is the tenant. We can also assign a name to the tenant. In this case, is oil. And in the spec section, we can assign some owners to the tenant. And in this case, we have the owner that is a user, and the user is named Alice. So these are the minimal requirements to create a tenant. So we have to assign a name and an owner to the tenant. But of course, we can also assign more parameters to the tenant. So a possible example that we can have is the parameter to limit the namespaces that a tenant can have. So if you limit the namespaces to 3 namespaces, the tenant can create 3 namespaces as a maximum values. So he can essentially delete them, but it cannot create more than 3 namespaces. So this is a little overview about Capsule and how it works. You can see that Capsule is installed on top of Kubernetes, so behind Kubernetes operator, and the main functionality of Capsule is to manage the different tenants. So using Capsule, you can have a better management of the tenants. And in this example, each tenant has 3 namespaces. So they can deploy application on them. They can manage the application, and they can have some limits regarding the behavior. So that said, after this fast overview about Capsule, I would talk about the charm. The charm is essentially an artifact that is manageable using Juju. In our specific case, so for the Capsule charm, this artifact is made for Kubernetes, but you can think to this artifact also as an application for your Linux distribution. So using Juju, you can essentially install the application or even configure the application. What essentially contains an artifact is ops code that is packaged, and the code inside this artifact is Python code. So it is really intuitive and easy to use. Also, thanks to the SDK that Canonical provides. And in the end, in the image, you can see an example of the marketplace for these applications. So the marketplace for the charms that is named Charm Hub. In this page, you can essentially search. You can retrieve information about your favorite charms. You can, for example, learn how to install them and how to configure them, because there are some section dedicated to these things. So let's see in the example our Capsule page on Charm Hub. So in the main page, we have an introduction about what is Capsule and how it works with Charm. You can also see that it is based for the Kubernetes platform, and you have also the command to install Capsule as a charm. So using Juju deploy capsule -k8s. But navigating in the web page, you can read the tab about the configuration. So you can learn how to configure the capsule charm operator using Juju. So you have different parameters. So for example, the forced tenant prefix, or the protected namespace regex, or even the user groups. So in this section, for each charm, you can essentially understand how to configure the charm. As the last part, I wanted to explain the anatomy of a charm, highlighting the most important points that we encountered during the development. So as you can see, I wanted to list the models, the deploy, and some internals about the SDK, and in the end, also the tests that are always really important. So let's start with the models. So the models are a concept that is born in the Charm ecosystem. So the model is essentially a workspace, and if you work if you are working developing a charm for the Kubernetes platform, so essentially you are working on a Charmed Kubernetes distribution, you are essentially creating a namespace. So the model is a namespace on Kubernetes. In this workspace, you can essentially deploy the application that you are developing, and these models are managed by the Juju controller. So having this, you can deploy your application and manage the life cycle inside the model. You can create the model using the command juju add model, followed by the model that you want. And after the model, you have to deploy your application. So the deploy part is, as the name say, the phase that you have to do in order to deploy your application in the Charmed ecosystem. So the deploy is also a command that you can use using Juju. And as we have seen before, you can essentially run Juju deploy followed by the application name. One important thing that we found during the development is that when you deploy an application in the Kubernetes ecosystem, the application is deployed as a stateful set. So when you create a deployment inside Kubernetes, you are creating a Kubernetes pod that has at least 2 containers. And the first container is the Charm container, that is the code that you write in order to manage the application. So using the Charm container, you will be allowed to manage the application lifecycle, so the installation, the configuration, and managing the events using Juju. So with the Charm container, you have a sort of a interface that you can use to interact with the application. The other container instead is, of course, the application container. So now I wanted to talk about the internals. As you can see in the list, I mentioned the most common Python modules. So if you are developing a charm, this could be really useful to know the most common modules that you can use inside your charm. But also some built-ins that you can find inside the Python framework to write charms. So the hooks, the statuses, and the final one is Pebble. That is a component that makes a sort of supervisoring about your application. So let's start with the modules. So the main modules that you are going to use if you are developing a charm are Lightcube and the Ops framework. So for Lightcube, as the name say, this is a module that you can use to manage the Kubernetes resources. So if you need, for example, to create a service or even read some existing resources, you have to use Lightcube. This is not a Canonical project, but it is heavily contributed by Canonical peoples. And as a second one, but probably the most important one, the Ops framework that is developed by Canonical, and it is the framework that you have to use in order to create the charm. So is the framework that provide and exposes the built-in for the charm itself. So as we will see in the next slide, an example of this built-in are the hooks. that are provided, as I said, by the ops framework, and they essentially are used inside the charm in order to allow you to attach some actions to certain events. So as you can see in the example, we use the observe function to attach the event to a specific function. So this example is related to our capsule charm, and so we managed the installation phase, then also the capsule Pebble ready event, and in the end also the config changed event. So having this event, you can attach the functions that you want to code, and in this way you are able to manage the life cycle of the charm, basing your behaviors with the events. Another important thing are the statuses. The statuses are let's say that there are different kind of statuses. There are statuses for the applications, but also statuses for the Juju agents. What we are going to talk about are the status for the application. So the status that you can code and that you have to use in order to notify the final user about the status of your application. So as I wrote in the slide, they reports the status of each application that is deployed. The most common statuses, also in our charm, are the active status and the blocked status. As you can see in the example, this is our uninstall function, so the function that we attached to the hook for the install event. And what we are trying to do is to create a Kubernetes, some Kubernetes resources, and knowing that this action can create some error, so the action could fail. We essentially wrapped the function inside a try except, and in case the function fail for some reason, we can inform the final user that the status of the application is blocked. So for the internals, the last subject that I want to talk is Pebble. Pebble is a lightweight API-driven process supervisor that is designed for specifically for the charms, and his main function is to replace the container entry point. So using Pebble, you can have a better management of your application, because it essentially override the entry point, and it can essentially take the leadership or the management of the application. So let's see the example. In our case, we created a Pebble layer that is a data structure with some configuration. Specifically, we are using the override function that is the replace. We are overriding, or better, we are telling Pebble to use the following command. So to run Capsule, you have to run manager followed by some CLI flags. We are informing Pebble about the startup behavior that we wanted to have, so it is enabled. And we are also passing some environment variable in order to run Capsule properly. In the end, we also set the on failure configuration with the ignore value. So that said, let's talk about the test. a few words about the Tox project. We really we really advise you to use the Tox project. It is a utility that allow you to automate your test. So it is really useful, especially when you run it inside a pipeline. But the most important part of the tests are is the ops test, the ops test framework that is developed by Canonical and is used to write a better test for your Charm application. So in the example, you can see our test that is named test build and deploy, where essentially we build the charm and deploy it with the right configuration. And in the end, we try to set some values in order to check if the charm is working properly. So in the end, we can see the GitHub action that we used and that we developed in order to make the test run. So we have 3 steps. The steps are used to download the Charm source code. The second step is to set up the environment. So we are essentially setting up a micro-KTS and passing to micro-KTS the default model where we are going to install the charm. And in the end, we run the integration test with the Tox, so using Tox-E integration. And in this case, we can have an automated pipeline to run the test with Charm. So the talk is finished. Thanks for your attention. If you want to ask me something, feel free to do writing me to this email, which is alessio@classics.io. So back to you, David.